The planet Earth is only a tiny part of the universe. It is the only known abode of living species. We are yet to find the presence of life anywhere else within the universe. Only the Earth has all the elements required to support life. There is water to satisfy thirst, air to breathe, fertile soil to produce food, and abundance of other natural resources to sustain life. Over and above all these, we have the sun, the source of all energies and the provider of a favorable temperature that helps the growth and distribution of plants and animals. Because of this extraordinary environment, creation, evolution, and sustenance of life on this planet have been possible. Amounts to 379.3 million square kilometers. Yet many people still do not get sufficient good quality water. This is largely because of improper management of this most invaluable resource. 97% of Earth's huge water resource exists in oceans and is not suitable for consumption directly. It is interesting to note that the remaining 3% of fresh water is also not easily available. Out of the 3% of fresh water, 2.31% is frozen in glaciers, 0.66% is locked as groundwater within the Earth's crust, and 0.1% is there in rivers, lakes, ponds, and pools. The remaining 0.018% is the biological water, and 0.001% exists as water vapor. That is, only 0.69% of fresh water is easily available to us for consumption. We human beings are profoundly dependent upon this tiny fraction of fresh water to meet our daily domestic and industrial requirements. It is estimated that on an average, a human being requires about 70,000 liters of water during his entire lifetime. We use water by drawing it out from where it is naturally present. We can also use it as it is, for navigation, boating, or swimming. The supply of water for domestic purposes must be pure and wholesome. Now, when we refer to wholesome water, we mean water which may be consumed without risk from its chemical or bacterial content. Such water must be free from suspended matter or color. It must have no odor, no taste, and must be free from pathogenic bacteria or organisms. Furthermore, this kind of water must not have any dissolved materials, either organic or mineral, which might render it unsafe for health. Keeping all this in mind, international organizations like the Bureau of Indian Standard, the Indian Council of Medical Research, the Ministry of Works and Housing, and the World Health Organization have set standards for the supply of domestic water. To supply water of prescribed standard, water from a properly selected source should be submitted to an adequate system for purification. In the industry, we use a lot of water for cooling, power generation, and also waste disposal. Water is synonymous with life. It is blessed with some very unusual physiochemical properties. It can dissolve a number of substances without changing their chemical nature. Accordingly, it plays a very important role in the transporting of materials within the body. Water acts as an internal and external medium for a number of living organisms, including human beings. Our blood is mostly water. It supplies food and oxygen to different cells of our body. In higher plants, the nutrients dissolved in water are carried from roots to different parts through the xylem. Often, water sources are contaminated with pathogenic organisms, toxic chemicals, agricultural chemicals, or heavy metals. This kind of contaminated water is known as polluted water, and the phenomenon is known as water pollution. The World Health Organization defines pollutants as foreign substances either from natural or anthropogenic sources contaminated with water supplies. These may be harmful to life because of their toxicity and reduction of normal oxygen level of water. They are aesthetically unsuitable and spread epidemic diseases. Pollutants may contaminate water in various ways. When any change occurs with regard to the color, odor, density, turbidity, taste, and thermal property of the water, it is known as physical pollution of the water. Chemical pollution of water causes changes in acidity, alkalinity or pH, dissolved oxygen and other gases. Bacteria, viruses, algae, protozoa, rotifers and plant toxins bring about biological pollution of water. They create different infections and give rise to different diseases such as cholera, typhoid, dysentery, gastroenteritis, hepatitis and polio. Physiological pollution brings about changes in the physiological properties of water. For example, chlorination of water converts the phenol to ortho or paraphenol, producing a very offensive odor and makes the water taste just like medicines. Different means pollute different surface water bodies. Among these, the most important is surface runoff. The sand and silt particles carried from the soil to water constitute very serious pollutants. Silting can choke rivers and irrigation channels, and many edible fishes are unable to spawn on the silted gravel bed. These days, large amounts of chemical fertilizers and pesticides are used to increase agricultural yield. Some of these chemical fertilizers and pesticides, in the form of runoff, come to the irrigation canals, drainage channels, and ultimately to the nearby water bodies. Surface runoff from the towns, cities, and highways contaminate the nearby water bodies and pollute the same. Most of the detergents have phosphates as their major ingredient, which is an important nutrient for the growth of algae and ultimately gives rise to algal bloom. When algae die, they add more organic content to the water. This ultimately reduces the level of dissolved oxygen in the water. This phenomenon is known as eutrophication. What you see here is municipal sewage. This type of municipal sewage consists of the excreta and nitrogenous wastes of animals. It is rich in organic matter and also in nitrogenous compounds. When untreated or partially treated sewage, such as this, is allowed to be entered into water bodies, it reduces the oxygen levels of the water bodies. In addition, it contaminates it with pathogenic organisms and increases the nitrogenous compounds such as ammonia. Because water is essential to the development of industry, factories are congregated along riverbanks, where the rivers provide a convenient conduit for their wastes. By the early years of this century, the concentrations of industrial effluents had risen to levels high enough to kill all organisms in most of the rivers in the more heavily industrialized regions of the world. Industrial discharges are not the only source of the contaminants which enter the sea. All over the world, communities living near the coast have found the sea the cheapest and most convenient sink into which to pour their sewage, much of it untreated. Treated and untreated discharges from various industrial establishments are capable of causing dangerous water pollution. They at times contaminate the water bodies with toxic chemicals and even with heavy metals. They raise the temperature of the receiving water body and increase the metabolic rate and oxygen demand of the microorganisms. This results in the depletion of oxygen, which makes it all the more difficult for the fish fauna to survive. Therefore, the entire ecological balance of a stream can be affected by thermal pollution. 98% of the fresh water on Earth lies below its surface. Of the fresh water that lies below the surface, 90% satisfies the description of groundwater. Groundwater acts as a reservoir by virtue of large pore spaces in earth materials. Groundwater is the source of water for wells and springs. That is the recommended source of water for rural domestic use. It has been found that the underground sources of water in some of the larger cities are being polluted. Domestic wastes and the methods of their disposal are of primary concern in urban area groundwater pollution. Partly buried and partly incorporated solid wastes percolate down and contaminate the groundwater by adding pathogenic organisms and toxic metals. Raw sewage dumped in shallow soak pits and seepage from a polluted lake, pond or stream also pollutes the groundwater. Disposal of this kind of industrial effluent directly on the ground also contaminates groundwater resources with hazardous organic and inorganic chemicals and toxic heavy metals. Fertilizers, pesticides, herbicides and animal wastes are constantly being added to the water in these agricultural fields. The leach from this agricultural land containing nitrates, phosphates, heavy metals and potash move downwards with the percolating water to join the aquifer below, and this causes a danger for the groundwater. Water pollution can be controlled or managed in a number of ways. For example, domestic sewage or wastewater must be treated in a sewage treatment plant. Likewise, industrial effluents must be treated in an effluent treatment plant. Industries must be allowed to discharge their effluents only after they meet with the specifications that are laid down by central or state-level pollution control boards. And that's not all. We should stop the use of chemical pesticides in the agricultural fields and instead promote the use of eco-friendly pesticides. Even more remains to be done. We must keep a stringent watch on the levels of toxicity in surface and groundwater and in the biotic components of the aquatic ecosystems. Perhaps the most urgent need of the hour is to create public awareness about water pollution and its consequences.